Very good morning, dear children. Today we are going to see Unit 2 Electricity in your Term 2 book. Before we start our lesson, let's say our prayer. God grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. Amen. Dear children, we are going to learn about electricity, the basic things in your 6th standard. So, to motivate you, few questions were raised in your textbook. We use electricity in our day-to-day life. Have we ever wondered from where do we get this electricity? How does this electricity work? Can we imagine a day without electricity? No, it is very difficult for us. We practiced uh, many electric gadgets in our day-to-day life, so it is unimaginable to us. If you ask a grandfather, you can come to know a period without electricity. They use only oil lamp for light, cooked on firewood, coal. By the advent of electricity, our day-to-day life works are made very easy and the world is on our hands. What are the appliances those work on electricity? We can list them out. Yes. What are the materials those allow electricity to flow through? We can call them as conductors. Later we are going to learn them. What are electrical circuits? What are electrical cells and batteries? So we are going to learn in this lesson thoroughly. So to know the sources of electricity, one conversation is given in your textbook. So I would like to give you the gist of that conversation. So from where we get electricity? We get electricity from various sources like thermal power, hydel power, tidal power, wind power and solar power, etc. But apart from these resources, we also get electricity from some other things like cells, batteries. See the wall clock and our wristwatch, etc. work only not using wire. It is work with the battery. Yes. So that also produce electricity. So overall, water electricity, any device from which electricity is produced is called source of electricity. How can we call the sources of electricity? Any device from which electricity is produced is called the source of electricity. So they have given you a major electric power station in Tamil Nadu. Let's see them. Thermal station Neyveli, Ennur in Tiruvallur district. Hydel power station Mettur in Salem district, Babanasam in Tirunelveli district. Atomic power station Kalpakkam in Kanjipuram district, Kudangulam in Tirunelveli district. And windmills Aralvaimozhi in Kanyakumari district, Kayatharu in Tirunelveli district. So apart from these electric sources, solar panels which are prevalent in many places are used to produce electricity because it is a very useful and renewable energy source. So let's see the electric source one by one. To begin with that, thermal power station is the first. In thermal power station, the thermal energy generated by burning coal, diesel or gas is used to produce steam. So the steam, it is not, see, your mother may cook some boiled water to cook rice. Yes, if she close the boiling pot with a lid, after the steam rises, what will happen? If she doesn't notice that, the lid will automatically remove from the pot. How it happens? That's just because of the energy produced by the very heat steam. See, in the primitive stages, in the beginning, steam engine, the trains are working using steam engines. So steam have that much of power. So that powerful steam is used to produce electricity. That you must understand. Okay. The steam thus produced is used to rotate the turbine. While the turbine rotates, the coil of wire kept between the electromagnet rotates. This principle you will be learning in your 9th and 10th standard. Electromagnetic, in between the electromagnet, if the coil is rotated means electricity will be producing. That is known as induced current, induced EMF, induced current, electromotive force. Okay, due to electromagnetic induction, electricity is produced. Here, heat energy is converted into electrical energy. Everywhere the turbine will be, every power station, most of the power station, turbine will be rotated, and thereby electric power is produced using electromagnetic induction process. Is it clear? Next, hydel power station. In hydel power station, the turbine is made to rotate by the flow of water. In thermal power, the turbine is rotated with the help of steam. Here in hydel power, the turbine is rotated with the flow of water from dams to produce electricity. Here kinetic energy is converted into electrical energy. Hydel stations have long economic lives and low operating cost. Okay. Atomic power station. In atomic power station, nuclear energy is used to boil water. The steam thus produced is used to rotate the turbine, as in the case of thermal power station. Here, this heat energy is produced by atomic nuclear energy. Okay, there by heat energy, here by nuclear energy. As a result, electricity is produced. Atomic power stations are also called as nuclear power stations. Here, nuclear energy is converted into mechanical energy and then electrical energy. Next, windmill. In windmills, wind energy is used to rotate the turbine to produce electricity. Here, kinetic energy is converted into electrical energy. So, these are the 4 types explained in your 6th standard. Very basic things were explained. Later, you will be learning very deeply. Next, we move on to cell. A device that converts chemical energy into electrical energy is called a cell. A chemical solution which produces positive and negative ions is used as electrolyte. Two different metal plates are inserted into electrolyte as electrodes. Two metal plates are called as electrodes, in which it is put inside is known as electrolyte. Due to chemical reactions, one electrode gets positive charge and the other electrode gets negative charge, producing a continuous flow of current. Depending on the continuity of flow of electric current, cells are classified into 2 types. They are primary cells and secondary cells. Let's know about primary cells and secondary cells and their differences. First, primary cell. They cannot be recharged, so they can be used only once. Use and throw type. Okay, you can use one time and you can throw it. It will not be rechargeable. It is not a rechargeable battery. Hence, the primary cells are usually produced in small size only. Example, cells used in clocks, watches and toys etc. are primary cells. What about secondary cells? A cell that can be recharged many times is called as secondary cells. In your mobile phone, battery is used, it can be recharged again. Your laptop, battery is used, it can be recharged again. In some cases, big power banks are used, isn't it? Big batteries will be there and we can recharge those batteries again. Those are all examples for secondary cell. These cells can be recharged by passing electric current. So they can be used again and again. The size of the secondary cells can be small or even large depending upon the usage. While the secondary cells used in the mobile or in the size of a hand, the cells used in automobiles like cars and buses are larger and very heavy. So the cells used in your mobile is also secondary cell, whereas the cells used in the car and buses, the automobiles, the large one, huge one is also a secondary cell. That you must understand. Okay, it may be of any size. Example for secondary cells are used in mobile phone, laptops, emergency lamp and vehicle batteries. Next we shall see about battery. Often we call cells as batteries. However, only when 2 or more cells are combined together, they make a battery. A cell is a single unit that converts chemical energy into electrical energy, and a battery is a collection of cells. That is the difference. Simple difference, vocabulary change. Okay. Then electric circuit. In the beginning, a conversation takes place between grandfather and Selvi. Again, the same conversation is going there. Grandfather asked the Selvi to bring torchlight. While taking the torchlight, it fell down and the cell came out. She put the cell back and switched it on. The torchlight did not glow. This happens for many times at our home itself. Yes, she thought the torchlight was worn out. She was afraid that grandfather might scold her. She started crying. Her uncle came there and asked the reason for crying. She conveys the matter. Her uncle removed the cells and reversed them. See figure A and see figure B. You can easily identify the difference between figure A and figure B. I repeat, in figure A, plus minus of one battery and minus plus of one battery. So the connection is between minus and minus, same polarities. It cannot happen. You see the figure B, minus plus minus plus. The connection is between plus and minus. So opposite terminals, plus minus. Opposite terminal should be connected together for the passage of electricity. Okay. Now the torch glows. Selvi's face also glows. Uncle told her the reason and explained her about the electric circuit. So let's see what is inside. What is the inside view of torch? See the inside view. How the batteries are arranged. Plus minus. According to this type only battery should be arranged to glow the bulb. Otherwise the bulb will not glow. Is it clear? An electric circuit is the continuous or unbroken closed path, very important word, along which electric current flows from the positive terminal to the negative terminal of the battery. A circuit generally has four important things. First one, a cell or a battery. That is the source of electric current. Second one, connecting wires for carrying current. Third one, a bulb. It need not to be a bulb, it may be any electric device that consumes the electricity. Fourth one is a key or a switch. We should switch it on or off, then only the circuit will be allowed to pass through or cut down. This may be connected anywhere along the circuit to stop or allow the flow of current. Okay. Next, open circuit. We are going to see the two different circuits. One is open circuit, another one is closed circuit. In a circuit, if the key is in open means off condition, then electricity will not flow and the circuit is called as open circuit. The bulb will not glow in this circuit. If the switch is off means the bulb will not glow. It is openly known by you. The second thing is closed circuit. In a circuit, if the key is in closed condition means on, then electricity will flow and the circuit is called a closed circuit. The bulb will glow in this circuit. So only when the switch is closed, that is in on position, then only the bulb will glow. That is closed circuit. Okay. Can you make a simple switch on by simple things available to you? Yes, it is possible. You can do it by yourself. You try it at home with your father's assistance. Okay. Then let's see the types of circuit. Simple circuit, series circuit, parallel circuit. First thing is simple circuit. What is a simple circuit? A circuit consists of a cell, key, bulb and connecting wire is called a simple circuit. This thing you can easily do it at your home. You just buy a LED bulb, a battery and a connecting wire. It is very easy to form a simple circuit. Next is series circuit. If two or more bulbs are connected in series, then that type of circuit is called series circuit. If any one of the bulb is damaged or disconnected, the entire circuit will not work. You will learn about this till your 12th standard. So at this 6th standard, it is sufficient and enough for you. Okay. If any one thing is damaged or disconnected means the entire circuit will not work. This is all about series circuit in your 6th standard. Okay. Next, parallel circuit. If two or more bulbs are connected in parallel in a circuit, then that type of circuit is called parallel circuit. If any one of the bulb is damaged or disconnected, the other part of the circuit will work. So parallel circuit are used in homes. So at home, we use only parallel circuits. Now, symbols of electrical components has been given in your textbook. See the table clearly. First one is electric cell. Single cell is shown. The figure is shown. What is you see in your practically what you see. But in electric symbol, plus and minus terminal will be shown in like this only. This is the symbol. long straight long vertical line plus symbol, short vertical line minus symbol. Longer terminal refers positive and the shorter terminal refers a negative. Second one is battery. Battery, already we have seen that combination of the cell is called as battery. So plus, minus, plus, minus, plus, minus. So this is, it should started with plus and ended at minus. Be clear. Plus ஒரு இடத்துலையும் மைனஸ் ஒரு இடத்துலையும் இருக்கணும், ஒரு டெர்மினல்லையும் இருக்கணும். ரெண்டு பக்கமும் ப்ளஸ்ஸும் ரெண்டு பக்கமும் மைனஸும், ரெண்டு பக்கமும் பெரிய கோடும் ரெண்டு பக்கமும் சின்ன கோடும் போட்டிங்கன்னா உங்களோட சிம்பிள் தப்பு. ஒரு பக்கம் பெருசாக இருந்தால் முடிகிற இடம் சிறுசாக தான் இருக்கணும். 2 or more cells connected in series. Third thing is switch open. Switch open means it should not be connected. See the symbol very beautifully they have given. Switch is in off position. Switch closed. Closed means 2 dots close. Switch is in on position, the current will flow. Then electric bulb. Electric bulb, if it is not glowing means just a coil symbol will be drawn. The bulb does not glow. If the bulb is glowing means like sun rays may be drawn. The bulb glows. Connecting wire. You have seen the connecting wire at your home, but a simple line can be depicted, or it will be the symbol for the connecting wires. Okay. Next we need to see about conductors and insulators. What are conductors and what are insulators? Will electric current pass through all material? Through plastics? Through rubber? No, it will not flow. Then the materials which allow the current to pass through it are known as conductor, which will not allow to pass through it is called as insulators. Let's see them. What are conductor? The rate of flow of electric charge in a circuit is called electric current. The materials which allow electric charges to pass through them are called conductors. Example, many metals, copper, iron, aluminium, impure water, earth, etc. Even human body. Human body, very good example for conductor. Insulators, the material which do not allow electric charges to pass through them are called insulators or non-conductors. Plastics, glass, wood, rubber, china clay, ebonite, etc. are example for insulators. So that's why the copper wire in your figure, see the first picture, the copper wire is covered with plastic. Why? The copper wire is a good conductor, the plastic is a poor conductor, that is insulator. So to avoid accidents, to avoid any disaster, these insulators are used. Okay. So we should be very careful while we use electric gadgets. Safety measures to safeguard a person from electric shock. How can we safeguard a person from electric shock? Switch off the power supply. First you should not hurry up and touch that particular person. If you touch means the current will pass through your body also. So you should not touch. First you disconnect the power supply. Switch off the power supply. Second, remove the connection from the switch. You should remove the connection from the switch. Third, push him away using non-conducting materials like wood, rubber, etc. Give him first aid and take him to the nearest health center. So this is all about the things given in your 6th standard about electricity. I hope you all enjoy this lesson. All the best. God bless you. Thank you, girls.